Okay. Hopefully the audio is looking good. And we are live. Awesome. Okay. So we've got lots and lots of things to do. I'm very new to this process. So before I even get going, let me go ahead and refresh the chat. It should be available. Let's have a look. Excellent connection, system latency. Just wondering why the chat is not working. Never mind, there's only me here anyway. Anyway, I thought I'd do a live stream real quick just to demonstrate it. If you're wondering when I do the live streams, I'm looking around about 2 o'clock most weekdays. Oh, we have another viewer. Hello, other viewer. I don't know why my chat is not working, but I would love to have chat working. For some reason, it is not even working, so I don't know. First time ever doing this, so I can suck at this for the first time, but I'm not allowed to do it for another time. But anyway, we are basically, I'm going to actually get into coding principles. I'm going to start with more information about how to get started with Blankcanvas, and also some of the coding principles behind Blankcanvas as well. So first of all, I've moved Blankcanvas from GitHub to GitLab. So GitLab is now currently the home for the Blankcanvas repo. And again, if you're brand new, what is a repo? A repo is a place where you host and store your projects, but because they're coding projects, they get very complicated very quickly. So we need to have multiple branches. We need to have a way of managing things, looking at when things go live and looking at when things go off and so forth. So the whole reality of this is that I have GitLab. I have, if you go to gitlab.com/modcat/blankcanvas, you will be able to access and download this repo, and you'll be able to run the software. Now down here I've created a README so that you can get going. You will need to download Node.js, open a console window like let's say a nice little command prompt. It's rather huge, but there you go. You'll open up one of these guys, and then you would install Yarn, and you would download this repo, and you would target the directory where the repo exists, and then you would run the following command, yarn init bc. So once you've cd'd into your directory, into the directory where Blankcanvas is, you would run the following command. You would say yarn init bc. And the reason why I've created this init bc command is so that if you look at package.json, where this currently exists, what it will do is it will cd into every available directory that it needs to, for example, the desktop, the mobile, and the renderer directory, and it will install via yarn all of the packages that are required for what we currently have here. So that will get you going. So why am I talking about Blankcanvas now? Well, I've talked about it enough conceptually, but now it's time to talk about it programmatically. And I'm going to be doing live events where I'm actually going to show you the code that runs Blankcanvas. I'm going to show you how it runs on multiple devices, how I share, for example, the Feathers code that runs in the background. If you've ever heard of Feathers.js, if you haven't, I definitely recommend you check it out. But again, I will be covering it eventually. And so this is where these live streams are coming into this. The live streams are coming in because I want you to fully grasp and understand all of the concepts behind the software, and then we can get going. So for anybody that's just come on, this is where you go. gitlab.com modcat blankcanvas. You download this repo by clicking the clone button, and you go ahead and follow the instructions, and you will be able to get up and running with what I currently have here. And it will take some time because it is a very, very big repo. It's a big boy. So what are these directories over here? Well, first of all, you can ignore haxi.lib and vs code. These two directories are, one's for haxi and its precompiler, and I'll get into haxi in just a moment, and the other one is for VS Code. So this contains configurations for VS Code, this actual piece of software here. And if you haven't got VS Code, I recommend you get it because it's a lovely bit of software. It's completely free, available for Windows, Mac, and Linux. So that's none of importance, but the thing where we will be coding in is the desktop, docs, mobile, and renderer. These are the main folders and directories that contain our project. So desktop contains an Electron project with Nuxt embedded inside of it, and it also has feathers embedded inside of it. So I've actually taken feathers and I've embedded it inside of the desktop application. Then we have the docs. The docs will provide you all the information and documentation so that you can actually look at the artwork. So I am currently paying for designers to design out the interface. I can do it, but I like the idea of sharing it between people and sharing the workload. So under docs, you'll have the artwork that gives you the interface. You also have what is a mind map documentation, .odg. So if you haven't got LibreOffice, I recommend you do. This is where I've mapped out how the feathers backend will work in Blankcanvas. Then we have the front-end processes. So the front-end processes are things like, how does the graphical interface work? How does the graphical interface receive input from multiple users? Don't forget that with Blankcanvas, you can connect it on multiple devices. Multiple people can connect through those devices to the same document. And so it's a very live, very interactive, very real-time application. It's a very complex one, but it's actually very simple to do. Once you've mapped things out, so the feathers mind map is for the back end, the front-end processors.odg maps out the front-end processors, and the ideas is where I record down ideas, and I also date those ideas so that if anyone tries to patent my ideas later, and we all know which company that is, I have a means of evidence to say that I was the original creator of the idea. I originally put it into the public sphere, and that gives me more intellectual property. With any software that competes with very large software corporations, they always want to patent your idea and then cast it out. So this is why this project has to be open. It has to be free, and I have to share this information beforehand, because otherwise someone will patent the idea and I can't produce the idea. Then we have a mobile directory. This has something called native script view in here. So I actually have native script installed on my machine. Now native script lets you build an actual interface natively. So if I go native script, and if you love Vue.js like I do, and you love Nuxt, you will love native script view. So if you take a look at native script view, again, it's completely free. And they have full Vue.js integration. So you can actually build native applications for Android and iOS. And you can have that fully integrated into your application. It's an absolutely amazing tool. It's completely free. And you can learn more about the Vue.js side of native script. You can watch the video. You can also look at how easy it is to import and use inside of it. It's actually incredibly easy to get started with native script view, and I'm incredibly excited about this technology. But what that offers me is the ability to take what I've done in Vue on the desktop side of things with Electron and move that across to native script. And that's where the really clever bit comes in, where I've created a custom DOM structure and I've modeled what native script has done, because native script does not use, if you go to the docs, it does not use standard HTML components. It uses its own components. And so what I've done is I've modeled those components and said you can only use those types of components in the desktop version of the application. So whenever you build it for desktop, it will also build for native script view as well. So I can cover both Windows, Linux, and Mac with what we call Electron. And with Android and iOS, I will actually get, I will actually have sorry, my phone's going. I will have a native application for Android and iOS. Now let's take a quick look at Electron and how amazing that is. Again, all of this is open technology, and I'm sticking with open technology. So for example, you can see here that some very large applications are already using this technology. So you can see that Visual Studio Code itself, this application right here, is actually built in Electron. WhatsApp is built in Electron, Twitch, Slack, and InVision. So there are some very big names behind the Electron platform. It was originally started by GitHub, and it's gone from strength to strength. It's very easy to use. Basically, it's just a web browser that's stripped out. So it's not got the address bar. It's not got all these icons and everything. It doesn't look like a browser, but it is a browser. And it also has one more thing. It has Node.js integration. Node.js is where you can run JavaScript like C# or C++, where you can access the file system, you can access cameras, you can access the actual hardware inside of your computers. You can run native code actually inside of Node.js as well. So all it is a browser that's stripped down, and you get to style the interface. And it's got Node.js integration so that you can get access to the file system, to cameras, and to hardware. It's an absolutely fantastic technology. So that's what I've actually established. And also what I have done is I've embedded Nuxt into it. So let's go ahead and take a look at Nuxt. Again, it's an open technology. Now, a lot of people think that Nuxt is something different to Vue. If you know Vue, you know Nuxt. Nuxt is just a configuration of Vue. It's just a framework that uses Vue. So the components are the same, the way you program is the same, everything is the same, but Nuxt just makes it that little bit easier. You don't have to, for example, register components. You know, when you have single page applications, which is what Blankcanvas is, you have to register like different pages and you have to register these components here and there. That's a bit tedious. It's not necessary. So I don't do that here. I just use Nuxt. But note that that's only for the desktop. For native script Vue, you have to just use plain old Vue. You can't use Nuxt. I mean, I'm sure you can use Nuxt, but I haven't figured out how to get it integrated yet. So I've just left it as Vue. But it's a really intuitive framework. It's got wonderful documentation. It's got excellent examples. And the way that it deals with information and puts everything together is incredible. And if you're wondering, how do I get Vue projects to be SEO compatible? So for example, we know that Angular and React are not SEO compatible, meaning they don't render for Google and Bing and all of these other search engines. The way you do that is Nuxt. Nuxt will actually has the ability to pre-render your pages and actually display that to Google and so forth. So Vue doesn't necessarily let you do that, but Nuxt configures Vue so that it will enable you to actually pre-compile your code on the server before you deliver it. And that is how you get it compatible with search engines, but you also get all the awesomeness of a single page application. Nuxt is the future. So I've introduced you to a ton of technologies here, and we're still not done. The other technology that we have is under the renderer. So the renderer will take care of rendering the graphical elements, such as basically you have Photoshop, you have graphical user interfaces, and you got all the buttons around the side. I'm not talking about all the buttons and panels. I'm talking about the center bit where you add text and where you manipulate things and you can see what you're affecting. It's basically the canvas. So the renderer is the canvas. And the renderer uses the following technology. It uses something called Haxi. And this is amazing. If you've ever wanted to program in several programming languages, but you know you're going to stretch yourself, Haxi is perfect. Haxi is a strictly typed language, and I've come to appreciate strictly typed languages more and more as time progresses, because JavaScript is very loose. JavaScript is very, how shall we say, easy to make mistakes. And you could put a number where a number shouldn't be and a string where a number should be, and you kind of flip and you flop and you go around. So the idea of Haxi is that you don't have that. You have a very strict programming language. But the beauty of this programming language is it's not actually compiled in and of itself. So you know when you get C# or C++, then they're compiled. Haxi is a cross compiler. So what it actually does is it can transform the Haxi code into Node.js. It can convert it into JavaScript. It can convert Haxi code into Neko, which is their own like VM. It's kind of like Java. Speaking of Java, it can convert it into Java. So you don't have to know Java. You just have to know Haxi, and it will convert it to Node, C++, Python, C#, PHP, Java, Lua, and a whole host of others. And I do believe there is a project out there for Swift, the Swift programming language from Apple. And so this is actually amazing technology. Again, it's completely free. And something that you should know about Haxi is its awesome power. A lot of people underestimate these technologies. But the Unreal Engine, that is an award-winning engine. It's behind tons and tons of high-profile games. That's somebody's course. I do apologize. There we go, the Unreal Engine. One of the most realistic real-time engines in the world was programmed using Haxi. This is some of the stuff that they've actually managed to produce. This is a game, by the way. Look at the detail in this. This is incredible stuff. You can render scenes like this. It's amazing technology. Fortnite, again, the Unreal Engine is behind some very, very big games indeed. So that was actually purely built in Haxi, which is one of the best technologies in the world as far as I'm concerned. And I kind of want to take that because I don't just want to limit people on the renderer, because for a lot of games, WebGL will not be good enough. It's not good enough on mobile yet to really get the performance. It is on desktop, but it runs very hot. It runs very, very much not as fluid as native. Now, don't get me wrong, native code does run very hot as well. You can hear your GPU crying in the background. But the main purpose of this is that you give people freedom. Yeah, you give them the freedom to say whether they really want to publish it for the web or whether they want to publish it for wherever. Now, I'm sticking with JavaScript because most people know JavaScript. JavaScript is incredibly powerful now. JavaScript is also multi-threaded now as well. So when people say, well, it's not a multi-threaded language, it is. And I much prefer the event-driven model. So, what do I mean by event-driven? When you write a PHP script and you host it on your server, what happens is, when you have 1,000 people requesting that PHP script, Apache, or whichever platform you're using in the PHP engine, will thread it, which means what it will do is it will create multiple instances in memory of that program, and that program can be addressed at several points in memory. Why does it do this? Because if it's just one script in one thread, which is one processor, if you think about a tube that carries water, you know, everybody has to wait to get a little bit of water. Okay, just imagine people lining up trying to get water. They've all got jugs, they all want information, and your PHP script is coming down the pipes. The PHP script is the water in the pipes, and you've only got one thread, which is the pipe. Now imagine that it's multi-threaded. So from the water source, it's just the same water source, it's the same PHP script, but now you spread it over 5 or 6 pipelines. Now the people that are waiting for the water, they're waiting for the data, there is more access. It's multi-threaded. And the same thing happens in JavaScript, but PHP does that automatically, and a lot of other things do it automatically. And JavaScript has that functionality. But what is event-driven model? Well, the event-driven model is when you base it on events. So, for example, what happens is when you request something from a script, the script finishes processing, delivers the information back. Finishes processing, sends the information back. Someone else requests, finishes processing, information back. Event-driven process is not like that. So when you have to request, wait until that script is finished, and then leave, that has to be multi-threaded then. You have to have multiple threads because only one person can fill their jug up at one time. You've only got one pipe. Now, the beauty of event-driven is that everything is asynchronous, meaning everything can happen at different times, like a phone call. If you and me are on a phone call, it happens asynchronously. You can talk, and I can talk at the same time. I can talk randomly, you can talk randomly. So what that means is that one script is not blocked. It's event-driven, meaning someone requests something from that script does exactly what it's supposed to do asynchronously, and return that to the user. But if you had 5 users request from that one script without it being threaded, they each have an event. Each one of those events happens asynchronously. Okay? And it doesn't block the pipeline. So imagine, the way I can illustrate this metaphorically is you only have one pipe this time. It's not multi-threaded, but it can be multi-threaded. You have one pipeline, and at the end of the pipeline, you'll have a sprinkler system. And what will happen with that system is it will shoot the water out into the air, and it can go into everybody's jugs at the same time. And so what that means is you're event-driven. You're not blocking the chain that ultimately says 1 by 1 by 1. No, now it can be 5. It can be like 5 people who receive the information, and it just shoots out into all these different jugs, all these different pieces of information. So hopefully that makes sense. And then also on top of that, not only with event-driven processing, you've also got multi-threaded on top of it. Now, when you combine multi-threaded and when you combine event-driven processing of your scripts, it is magnificent. The performance that you get in that. Not only have you got the ability for 8 people to crowd round one pipe, you also have several pipes in which each pipe can take like 8 or 9 people. So it actually gives you an incredible level of performance, and people with Node.js applications, a lot of enterprise applications are now moving to Node.js. They're still in C#, things like that, but Node is actually coming up in that world, because it's actually very, very fast. So anyway, I'm going to get back to blank canvas. So the renderer is using this Haxi information, and that's for obvious reasons, because we want it to be able to export out to multiple things. I want them to be able to export out to C#. I want them to take their artwork and make it into games, or make it into... They can even use the Unreal Engine at this point in the background. So that's what's really amazing. And you have the source. That's where the app.haxi is. I'm just playing around with things right now. I haven't actually got to the point where I'm displaying things and working on those things. We're not even close to that stage yet. I can do it, but I'm not close to that because I've got a lot of other things to do in the project. So if we go back to the desktop, what do we have here? We have a standard Nux configuration. Your assets, they will control your styles. Now I'm using less. Less is pretty much exactly the same as SCSS, but it allows you JavaScript runtime, so you can actually compile less in the browser. And also less, it doesn't require all this C++. If you ever have problems with Sass and you've had problems with compiling Sass absolutely sucks when it breaks your project. So less just gives you less problems. That's the way I look at it. It's exactly the same as Sass. It has pretty much, syntactically, it's exactly the same, apart from a few tidbits like how you declare variables. But everything else is pretty much exactly the same. So I don't see any point in using Sass or SCSS. It's just bloated, and it just causes so much problems. I've had enough of Sass. Whereas less has caused me absolutely no problems whatsoever. It's all like JavaScript. It's fantastic. So you've got your styles, you've got your images. There's going to be a lot more images added. I'm going to probably divide this down into interfaces and things that we can use. But all these icons and so forth. You also have fonts. The main font will be Open Sans. That will be the main font for the entire interface. You have components. Now in your components you'll have classes. I'm still not sure whether I want classes in the components directory, but classes will be things like every time you create a filter, there'll be a class for that filter. Every time you create an object, for example, a rectangle or a shape or something like that, it will have a class associated with it. And that helps us understand the object. It helps us understand when it was created, how it's created, and hold those properties. Then we have panels. Now what this is going to be is it's going to be a lot like Blender. And if you haven't seen Blender, it will be using Blender in the background, which is blender.org. It is a free and open source technology. And so with Blender, with 2.83, you can see how amazing it is. You can do lots and lots of amazing things with Blender. But I'm going to model Blankcanvas's interface using the same Blender. I'm going to use the same interface where you can divide it up, you can cut it horizontally, you can cut it vertically, and you can set your panels. And so that's what I'm going to do here. So you're going to have all these panel types, and you can see under the panels directory that there is all these different panels that you can associate with a section inside of the software. Next up we have shop. So I'm going to have an amazing shopping cart. Okay, this shopping cart is going to be absolutely incredible. I've got the designs for it. I just need to put them together. But the shopping cart will allow you to buy multiple different types of assets and services using many third-party services, I may add. And it just allows people an amazing gateway and an easy payment method. So your components are divided up into classes, which is the main objects, panels, which is the different panels that you have open. So for example, here I have a panel which has the files. Here I have another panel for the code editor. Here I have another panel for the terminal. These will be classed as panels. And then you'll have the shop, which is the actual store. But I don't like calling it the store because Nuxt has its own store for a very different purpose. We also have the distribution folder. You don't have to worry about the distribution folder. That is of no consequence. That is just when you compile your Nuxt project. Layouts. We have the default layout. The default layout contains the header, the main Nuxt content, and the terminal. And I do have some part of the terminal working, by the way, even in the back end. So the terminal is a lot like what you have down here, where you'll actually be able to access and run code. Next up, we have mix-ins. Mix-ins are shared functionality. Basically, their functionality is functionality that you can share between components. It's a really useful feature. It's not advanced. All it is like if you want a method to be copied across multiple components, you would import the mix in and you would import it into your component, and I can show you how to do that later. But that ultimately means that you write the code once and you don't need to copy and paste it, and you also don't need to put it in the Vuex store because it might not work in the Vuex store. It might have to work on the component level or the instance level, and so that is where that guy comes in. Then we have the node modules. This is installed all again for you. We have pages, so each one of those is pages. We have plugins, which allow us to plug in client-side software, native script elements. I'm creating all of the native script elements right here, and we'll get into this at another live stream. And you also have the server. The server is the Feathers instance. And so the server is a whole Feathers backend that runs on your local server and is available on your local network. So your machines can actually run locally between one another. So for example, if you had your iPhone, and I will actually demonstrate this for you now, if you have your iPhone, if you have multiple devices, get them handy. Then you also have static assets. These are just included into the project. Then you've got the store itself. So the store has multiple modules. So it's got connection modules, documents, modules, all sorts of things, and they get compiled. It's got shop modules, service modules for messaging, profiling, images, child processors, you name it, it's in here. So the store is available globally throughout your application. So any JavaScript that's put in the store is available globally. Then we have some test. Now I'm going to be getting into Jest at a later point, but I've installed Jest on this so that we can run tests. And I realized the real importance of running tests because there's many operations that can happen, and we don't necessarily think of everything at the first go. And sometimes when you change something, you go, oh, that's working, but you've broken something else. So testing will really help the code stay robust. And every time you try and polymorph the code, it has to pass all the previous tests, including the new tests. And that is what's most important about the TDD, or test-driven model, in that one. You also have mobile. In the app directory, you've got everything for the app, and I'm pulling in some stuff from the desktop. So I'm actually pulling in components from this desktop project to this mobile app, and we'll get into that. I've gone over time. I've gone 4 minutes over, so it's okay. But I don't really want to get into that because it's quite in depth and it's very, very native, if you will. And then finally, we have the renderer, which again I've covered. So very quickly, after you've downloaded the project, targeted the project's directory, and make sure you've got yarn installed and Node.js installed. And then all you need to do is cd to the directory, do yarn init bc. It will start to download the project. Now, what I'm going to do is, as I've configured the desktop, I've configured it under the nuxt config. And I believe it's the nuxt config, or it will be the server configurations. It's been a long time since I've opened up excuse me, a lot of this. Basically, I've set it to the private IP address. So you have a private IP address. Everybody has a private IP address when you hook up to your router. So what I'm going to do now is I'm going to cd to the desktop, and then I'm going to do yarn, and then if I take a look at the package.json scripts, ignore me. So we do yarn desktop. Sorry, I forgot the command. So once you've installed everything, you cd to the desktop, you do yarn desktop, and what happens is it will actually compile for Electron, and I'll just fire up the application. It's nothing, it's not a big wow, and it's not like, oh my gosh, look at this, this is absolutely amazing type of thing. But you'll see a few errors. So you can see here we've got this first of all, and until the application starts running, it's running now. So it's saying Nux files is getting generated. It's compiling the client side. It can also compile the server side, which I'm not interested in, to be honest with you. I'm just interested in this. You can now see that it's starting to get from this IP address. This is actually my private IP address that my router's given me, 192.168.56.1. This means now that when I access this HTTP 912.168.56.1 and 1993, I can access the actual front end. There we go. It's loaded up. Again, there's no big wow. There's not much to look at here. And I know that it may seem a far way off, but this took a long time to get to where it is today. Come on. Thank you. Stupid piece of software. This is more Windows than anything else. It's got terrible window management when it comes to going from a 4K screen to a lower K screen. It just cocks up constantly. But never mind. Stream is for children, so I can't swear. But you know, you can see doc, stencil, video, da 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 da. Okay, and again, it's not perfect. It's not fully finished yet. It's gonna need a ton of work. This stuff, and it also has the terminal at the bottom as well. If I can make the window smaller, which I can't because Windows sucks. Balls. There we go. Okay, so, well, there you could see it. Okay, so here you can see that it has the terminal and the little bit at the bottom. That's all I've actually really done. It's just presentational, but I have actually integrated a lot of the back-end stuff that this requires. What am I doing here? I'm giving you an introduction, okay? I'm giving you the ability to peep into this project. Now, you are going to probably need to rewatch this several times because it's a massive project and it requires a lot of thought process. You need to understand Nuxt and you need to understand the command line, and our job as web developers has become exceedingly more complicated over the years, but actually with this complication comes a lot of simplicity, because once you've learnt it, a lot of the issues of having huge files and things that go wrong, we now have great package managers, we now have great systems in place. So you can see here that I've got the basics running. I also have the server running in the background. So if you actually take a look at this, you can see that it's running on this web address. And if I copy that web address, go into my browser, if I paste this in, you'll actually see that Blankcanvas is running on the local server. It's not just the local host. I could go onto another computer that's on the same network, type in the IP address, type in the port number, and you will literally be able to access everything from a web browser to a tablet to a smartphone, but it won't, the interface won't work on a smartphone because it's just too big. But it could work on a tablet, and also it can work on a variety of different devices. It can work in the browser and it can work outside the browser. This is why Blankcanvas has taken so long to get to this point. It's because an application like this hasn't really existed. Most applications just connect to a server, but I want it running locally as well as through a server, which I will provide that server for people to sign up to and basically share stuff in the cloud. But I also think that that's very wasteful to make people do that when most companies have their own internal networks, their own internal storage, their own internal backup systems. They don't need to purchase cloud storage. It's a very, very hefty expense. It's taxing the world as well because we have to constantly send things all over the Pacific and Atlantic. In this case, it all runs locally. It all runs very efficiently, and it all works amazingly. Now, I know it's not the most exciting live stream, I know, but this is the whole point, is that you get to grips with this software and you begin to see the start of this software. It's massive. It's huge. Even now, it's huge. And don't get me wrong, it's actually very simple to put together, and it will be very simple to put together, but I'm just waiting for designs. I'm getting the interface design, then I'm going to present that conceptually, and then hopefully I'm going to get some funding for this project, and hopefully I can get some programmers to come and join me in the project. It'll be a great thing for your portfolio, for you as a whole. So thank you so much. This is only the beginning. My lectures will get better than this, and hopefully everything will go really well. Thank you very much, guys. Bye.